All right, well, thanks all. In 20 minutes, it's tough to talk about what it takes to be successful with autonomous driving. So I'll try to take you on a quick roller coaster ride in terms of what we're seeing with both NVIDIA and AWS to be able to bring autonomous driving to life and what it means from an AI standpoint. But before we get into autonomous driving, just a high-level view from an application standpoint, when you look at what both NVIDIA and AWS have to bear, we look at everything from AI to analytics, things that NVIDIA has been well known for with our graphics cards around HPC and VDI and rendering, where ray tracing is reset, the ability to see things visually. And from an edge standpoint, connected devices of any kind, whether that's the vehicle that I'll be talking about, the device you take with you into the vehicle, or on the factory floor is certainly critical. I'm going to reference what AWS is doing with SageMaker in particular, as well as we're excited by the recent Outpost announcement. And then from a partner standpoint, Accenture is certainly one of many, but one that we work with closely for customers to get the most value out. And those of you who know about NVIDIA, what we do is take a very open approach. So we build out the frameworks and the libraries and the containers to make everything available to you to accelerate your AI efforts. And ultimately, when that manifests itself at AWS, in particular with the use case we're going to talk about, P3 certainly is where we see our customers developing what it takes to bring a self-driving car to life. So it's very much a complete workflow and feedback loop here, starting with the vehicle itself. And I'll talk later about the scale of images that are created with these data collection cars on the road that we need to then ingest and curate and ultimately label images. Oftentimes we'll see as many as 1 billion images can be created or collected, and only 3 million of those images will end up being labeled and used for the AI training to give you some sense of scale at the high level. And then I'll talk to you about what our own experience is because we're building the AI ourselves, what the scale is going to be required based on the DNNs for self-driving. And then ultimately from a safety standpoint and insurance, for one example, it's all about having a safe self-driving car. So we've got to simulate all the possible driving scenarios. And then there's also this concept of using all that data I collected up front and replaying it against the AI later to see that it'll work well. And when we take that one click lower, I'll talk to you again about the efficacy and the scale required for training. And with replay and simulation, NVIDIA has built a very purpose-built solution that allows you to both use our ray tracing capability to create a 3D synthetic view of the world, but then use those same 8-way GPU boxes to be able to take that torrent of data you collected up front and replay it so that it can run at super real time, which is really the critical importance here, so that you can both have the accuracy that's required with hardware in the loop on the actual in-vehicle hardware, but then also accelerate your testing using super real time in what we call a Constellation. At AWS on the training side, SageMaker and P3 instances are what our customers are using, our joint customers are using to be able to develop the AI and bring it to life. So scale, what are we talking about? If you think about NVIDIA's got a fleet of BB-8s driving around collecting data every day, in the 50-car fleet driving 6 hours a day, we're talking nearly 2 petabytes a day that's being collected. And I already mentioned to you this curation issue and labeling, and we've been at this for some number of years. We have others of our customers that are behind us in terms of the data that they're collecting. But once you have identified a good set of data, it's about looking for the corner cases. And so then you've got to curate it and label the right data. Active learning is a very interesting concept that we're using to be able to identify, would I already recognize that image, or do I need to send it through for labeling? In our case, we've got a team of over 1,000 people that are doing the labeling in India for us, so that ultimately then, in NVIDIA's case, we're blessed. Of course, we're NVIDIA. So we have our own Saturn V supercomputer loaded up with thousands of nodes where we're doing the training. And as I continue to talk, I'll give you a sense for the scale for your efforts. And then ultimately, we want to take that data once we've built the networks and replay it. And here we talk about thousands of hours. We have some of our customers that are talking about hundreds of thousands of hours where they want to replay that data and actually have it turned around in a day or 2 or 3 days. So hence my comments about super real time and how important that is. and then ultimately simulation, because it would take 100 vehicles driving on the road 500 years to actually drive every single possible global driving scenario. It's just not feasible. We can't wait that long. So simulation is super important to be able to create in a synthetic world using NVIDIA's ray tracing capability that vehicle driving as if it's on the road to be able to complete the testing. But to tie it back to Amazon and AWS where we are, from their perspective, they've got SageMaker from a workflow, but also SageMaker Ground Truth, where you can do the data labeling, do the image classification, look at LiDAR, draw bounding boxes around the images itself, do the segmentation that's required to be able to get the data at a good state that we can then develop the AI and the deep neural networks that are going to be required to be successful. So when we talk about the AI that's required for self-driving and the deep neural networks, what are we talking about? And when I say 20 or more deep neural networks, this is a view to give you some sense of what that means. The most complex of these is object detection. Is that a vehicle? Is that a boulder? Is that a bouncing bag flying down the road? And then we want to look at the inverse of that, free space detection. So not just is there something in front of me, but do I have a free space to drive? For level 2 and level 3 driving, we want to look at distance of the vehicle in front of me so that we can have safety. We want to look at path planning, lane planning, and look at the road markers that are on the road. We want to use LiDAR to be able to have AI that's highly effective at any time of the day. Multiple different bits of mapping. We need to look at signs, lights, road markings, surround. So as you can imagine, just with the outside of the vehicle, it's really complex. But for level 2 and level 3 driving, where a human still has to take over, now we care about what's happening inside the vehicle too. We want to know if we've got a distracted driver, so we look at things like gaze and eye openness and head pose. We want to see if we're looking down at our phone, so we do gesture recognition. Ultimately, for the AI cockpit of the future, and there's a great deal of announcements, and on the show floor you can see a great deal about this, or even things like gesture recognition, facial recognition, and ultimately in the AI cockpit of a level 5 driving car, we're going to see recommendations happening, and conversational AI will be able to recognize what you as passengers are talking about and actually bring that to life by having real-time recommendations delivered to you inside the cockpit of that self-driving vehicle. So when we talk about the DNNs that are required, this just gives you some set of them. It's certainly not comprehensive, but by itself, this is the 20 or more deep neural networks that we see are going to need to be required for a self-driving vehicle to be safe and on the road. Now, of course, doing this is challenging, and so how do we actually do this at super light speed? Well, at NVIDIA, what we've been working on from our GPU acceleration, we're super proud of winning the MLPerf awards and the reductions in time that we've been able to bring down from an AI development standpoint. If you can imagine that just 4 years ago, what would have taken 25 days to run, 2 years ago we cut down to 8 hours. Now we've gotten it down to just over a minute. So if you think about the acceleration from a compute standpoint and what we've been able to do as we continue to bring new technologies to market, this is just staggering in terms of the speed and the acceleration of the AI development. And just to give you a sense for some of the MLPerf awards that NVIDIA has just recently won, important ones for self-driving are things like object detection, which again is, I would argue, one of the most complex deep neural networks that needs to be developed, where we've been able to, at max scale, cut the training time to under 20 minutes. That in and itself is a huge accomplishment. We look at recurrent networks as well, conversational AI. Again, I think the AI cockpit of the future is going to be extremely meaningful. If you think about it, when we get to level 5 self-driving, safety will be something that we as a consumer will care greatly about, and that's why simulation and testing, which I'll talk about next, is so important. But when I'm a passenger in that vehicle, the things that I used to be loyal about, the performance of the vehicle, how it handles, these are things that I won't think about in a self-driving vehicle of the future. It's the luxury inside the cockpit. It's the experience that that manufacturer has with me when I'm inside that self-driving vehicle. This is what's going to drive loyalty in the future. So when I talked about the 20 or more deep neural networks, that doesn't even scratch the surface of where we'll be when conversational AI continues to expand. The advances in this space have just come on so rapidly in the last few years, and we're going to continue to see more and more of it. So a great deal of complexity. Now back to AWS. EC2 is certainly one part of their platform where we can do distributed learning. We, NVIDIA, have done a great deal of work with Kubernetes. And so AWS too has brought that to life. And SageMaker and their batch functions will allow you to be able to accelerate your pipelines and the development effort doing this work on AWS. And then specifically what they've done very recently is adopted. I talked about the advances that we've made from 2017 to 2019. Now in the P3D and large instances, you've got the much larger GPU memory footprint where we can see 2x improvements. The vCPU has gone up and we see significant improvements. Big things here too though on the networking throughput. And of course you've heard about NVIDIA's acquisition of Mellanox, a partner of ours for many years, now incorporating more on the networking side. Huge speed ups that we're seeing on the network throughput, which for these large networks for self-driving, where we're talking about running from a training standpoint, 3 million to 6 million, even 8 million images through when we're doing object detection, this networking throughput is extremely important. And so the good news is, for those of you looking to accelerate your pipelines at AWS, the P3D and large instances will give you that advanced throughput that's required. Now you might be asking yourself, okay, that seems like a great deal of deep neural networks that need to be developed. What kind of scale am I going to need to be successful? And the answer is, because we're NVIDIA, the beautiful thing is that we don't have to just look at the benchmarks, things like the MLPerf that we've won, but we're actually well down the path for having developed these networks ourselves. So all that we had to do was look backwards at our NVIDIA Saturn V supercomputer and ask ourselves what scale was required at certain points along the journey. And it's observed scale. It's not an extrapolation. It's not just a benchmark. It's what we were literally consuming to do the work. And so when we were in the early days of our development for level 2 and level 3 driving, and we had just 10 deep neural networks that we had developed, and we were having 10 parallel experiments going on at any given time. And what I mean by a parallel experiment is, up front, I'm just doing some exploration of the data. Does my deep neural network even work well? As I continue to do development, I'm changing hyperparameters. I'm trying to optimize the model. So that's what we mean by parallel experiments. Well, a complex model, we knew just one AWS P3DN, so one 8-way GPU box, it would take one deep neural network an entire day to run. Now, it's actually 21 hours if we're honest, but doing CEO math, one deep neural network, one 8-way GPU, 1 day to run. I have 10 DNNs. I'm doing 10 parallel experiments. We were consuming 100 of these 8-way boxes, 100 of the P3DNs at that point in time. We're now well down a path where we're doing 25 or more deep neural networks. We've got a very large team of data scientists. We're doing 25 to 30 parallel experiments at a time on all those networks. Hence my comment earlier about consuming thousands of nodes in our Saturn V supercomputer. We have customers around the world that have reached that scale themselves, that are already doing this work. And as you could imagine, it's the customers that are leading the work with level 4+ driving right now. So that's the scale that we're seeing it's going to take to be successful. Now I want to pivot to, okay, I've built that AI. How do I now test and know with confidence that it's going to work well? And what we're seeing from a validation standpoint in the marketplace is that it's a pyramid type approach, and that a V&V methodology starts with customers running, say, 70 to 80% of their testing on that data that they already collected that's available. And so they're doing replay for, say, 70 to 80% of the testing, and partly because this is where I can get the super real-time performance, 3x, 4x, 5x faster than I would with real-time performance. And so we see a great deal of this by component level. We mean testing a feature of the AI and seeing that that AI actually works, knowing that we would have recognized an object, knowing that that would have created control to actuate the brakes to be pressed, And so we do that testing with the images that we've already collected. But then if we think about large-scale simulation where I want to test the actual in-vehicle SoC, but also the other ECUs, you want to have perfect confidence that the AI will work with that actual in-vehicle hardware. And so here we need to do enough testing and simulation to look at every one of those possible global driving scenarios. And this could be up to 100 million global driving scenarios. If you consider NHTSA has 50, NCAP is around 50, base driving scenarios. Now imagine there's 100 or more different environmental conditions, snow, rain, wind, etc. There's transient conditions, a cutoff at 80 miles an hour. And then in the AI practice, fault injections. A vehicle appeared right in front of me or disappeared while I was driving. This is what can cause 100 million or more scenarios that need to be tested, and where simulation hill will be so important. And that will take up, let's say, 10 to 15, maybe upwards to 20% of the testing, and you just leave 2 to 5% of the testing to be at the highest fidelity of the actual on-road vehicle. And so to visually, and I'm a visual thinker, to give you a sense for this, what we're doing with that Constellation box is enabling both the simulated world to be created with high-end imagery from NVIDIA's ray tracing, or actually just replaying the DNNs that I've built using the 8-way GPU to be able to do the same. So one infrastructure to be able to do both. We find huge advantages even from an administrative and an operational standpoint. And the reality is simulation's a tool chain. So it's not just about simulating the world, it's about understanding how's the vehicle performing, so the dynamics of the vehicle. So we have APIs built for folks like IPG and CarMaker, for example. You want to be able to bring in HD maps, and so we have APIs to the environment model. We've got system integrators that will do work. It's going to be critical that every sensor is actually tested. So cameras, radar, LiDAR, IMU, and then traffic models, so we can actually simulate what would traffic patterns look like. So we've built the API to do that. And AWS follows a similar methodology from their standpoint. They look at the workflow of ingesting the data, flowing it through to resimulation initially, so good validation to our methodology and what we see and what they're seeing in the marketplace, and then ultimately simulation itself that can be run at AWS. And so to begin to round things out a bit, we think about NVIDIA, and back to my comments about being an open platform. NGC is what NVIDIA has built that makes everything available via our containers, so you can get at and work with SageMaker and Batch and EC2 and those P3DNs. CUDA is the glue that ties it all together, and it enables not just HPC and Viz and rendering, things that we've been known for years, but the AI development as well. And then ultimately, while I didn't spend any time on it in my talk today, Rapids is an open source function from NVIDIA where we're accelerating traditional big data analytics. Imagine 50 times speed up of traditional machine learning algorithms using Rapids as an open source technology. From an acceleration standpoint, again, there's 50 or more containers that we've talked about. We've got model training scripts available, workflows. And what I also want to mention, and we've got some of our team behind me that are here to do the work, is that NVIDIA also has a group of what we call developer relations that can work with you to help figure out how to get the most out of your work with NVIDIA GPUs at AWS, so that you can be like some of the great customers that NVIDIA and AWS together. And one I'll highlight is Toyota Research Institute, AD, who went all in with NVIDIA, who are using the P3 instances to be able to do their AI development, who have the Drive Constellation to be able to do all their simulation and testing, who have that system on chip from NVIDIA to be able to go end-to-end and develop the AI, test the AI, ensure that it works. So we were super excited to announce this several months back. There's a really great work that's going on between NVIDIA and TRIAD. And as it turns out, as I already mentioned, TRIAD had already gotten really good effort out of their work with AWS and their P3 instances, huge speed ups. So this was just a natural extension for them to build the AI there and then do all the simulation and testing with NVIDIA's in-vehicle hardware. So with that, I thank you for your time.